Function Basics, Chapter 11.1. We're going to be talking about the formal definition of a function. A function is a process for turning numbers into potentially different numbers. It will be consistent. When the process is applied to a particular number, you will always get the same result. Sometimes this process is not very mathematical in the classical sense. So, for instance, if a G number, a PCCID number, can be used to find a student's name, that process is going to have one output. Given the number of people sharing a $20 pizza, find the cost per person. That process would be the same. Sometimes the process is more formula-based, and that's a lot of what we'll be focusing on. So, for instance, the square root symbol is a process that turns numbers into their principal square roots. I'm going to fill out the first table as an example, and I will have you independently do the square example. So, in the square root, I'm thinking about what number times itself makes 25. And the answer to that would be 5. The square root of 1 over 16 is 1 over 4. Now the square root of 15, we're going to have to do a decimal approximate for that one. Now, had they asked me the square root of 16, we could figure that out pretty nicely, but the square root of 15 is, and I'm going to use an approximately equals to symbol here, 3 point, and I recommend you go to the 4th decimal place when rounding. It's what they do in stats class. Now, when I typed it into my calculator, I had a 298, and I just said round to the 4th decimal place, so that would be that 9 place. So the 8 is going to round the 9 up, and because when you round 9 up, you get a 10, this will round to about 3873. Get rid of that one. Square root of 20, again, square root of 20. We'll have to do a decimal approximate for that one. And this one is 4.4721. And because the number after 1 was a 3, I can just leave the 1 alone. The square root of negative 4. Oh, geez. That's unpleasant, because 2 times 2 makes 4, which is nice. Negative 2 times negative 2 also makes 4, but positive 4. So there's no way to make negative 4 and be happy with real numbers. So you can either say non-real answer, and later on, when we talk about imaginary numbers, or in a later class, you will be able to say it's 2i, I for imaginary, but don't let that scare you. You can just say non-real answer for us today. What you're going to show me is that you can fill out this in-out chart for x squared. That is the thing to the right. Now, we know what a function is. It's a rule, a process that takes something and outputs something else, and it's consistent. We're also going to name a function. What we'll say here is the name of the function, and a lot of times mathematicians aren't really good at giving names. They just tend to use letters. So in the example below, they're saying f is its name, and you would have your x in parentheses, the variable that you're going to be using. And the way that this is pronounced, this f parentheses x, is f of x. And we say of to remind us that f is a process that we're about to apply to an input value. For instance, I'm going to compare maybe a place where you're more comfortable, where you would have y equals 3x plus 4. And so we could fill out an in-out chart for this, hopefully. That's not too unfamiliar. So if I put negative 1 in for x, and I multiply it by 3, and then I add 4 to it, I would get the output of negative 1. If I put in 0, I would get the output of 4, and it makes me feel like I made a mistake up here. Output of 1. Then I would have the output of 7, 10, and 13. Now f of x is the same thing, except instead of having a y in that position, we have an f of x in that position. But the outputs will be exactly the same. So it is exactly what you're used to. The only thing that's changed here is just its name. And what that allows us to do is it allows us to take a point like -1, 1, or 1, 7, and add a little bit more language. We could say f of 1 equals 7, or f of -1 equals 1. It's giving us our x value and our y value in more of a sentence. And similar, these points do the same thing. So it's all the same. You've done this before, just a little bit of notation. You have also read graphs before. So I'm going to start this, but you're going to finish it. So the input, and then we'll have some output elevations. And the first question is, how is elevation parentheses t pronounced? Describe what this function does. All right, so it's pronounced the elevation of t. And what does it do? At various times, we're going to get output elevation. So if we input a time, we will get the output of an elevation. So we must be hiking up a mountain. And I see that there's 9 times down, and 1, 2, 3, 4, 5, 6, 7, 8 boxes. Well, oh well, I'm going to add a 9th box just so I can have it be neat. Okay, so I'm going to say at time 0, time 10, 20, 30, and so forth. Apparently I can't count. I had to add 2 boxes. If you wanted to skip a few, that's fine. What is the output elevation? At 0, it was 0. At 10, it was 15. And I am just reading these points. X was 0 at 0, and the height, our elevation, was 0. Then our height became 15. All right, you fill out the rest of this, please. So this will be done independently. And we're going to use that, by we I mean you, are going to use that to answer the questions below. When does the function appear to be steady? When does it appear to be decreasing? If this is a map of elevation for a hiking trail, when are the hikers walking uphill? Interpret elevation of 40 in everyday English. What does it mean? So explain it to someone. When was the elevation 25 feet? Write the answer in function notation and everyday English. So function notation, just to remind you, is this f of like 3 equals 5 business. So when they say that, they want the answer to look like this, but obviously the answer is not f of 3 equals 5, it's something else. All right, so we now have several ways to represent input-output pairs. You have function notation. Before this class, you've been doing like input-output XY pairs, or x, comma, f of x. Same thing, so input-output would have looked like this, xy. And you could have made a table, which we've done, of inputs and outputs. We also have formulas and equations. You should have a few things in your bag of tricks here for linear equations prior to this class. If you need a review on linear equations, please let me know. But I'm going to expect that you know slope-intercept form, y equals mx plus b form. I will say f of x equals mx plus b, but same thing. If you put in 0 for x, you will be finding your y-intercept. And if you put in 0 for y, you'll be finding your x-intercept, or your horizontal intercept or your vertical intercept. So you should know these 3 things coming in. If you don't, let me know and I can give you some review material. Using that, I have given you a function defined by f of t equals 6t minus 5. The first question says find f of 0. So it's telling us that the t value that we want to put in is 0. The first thing I will do is write the equation that we're working with. And then it's telling me that f of 0 is what I want to find. And so you can see that the t is 0. So we'll replace the t with 0. And we will get 0 minus 5. F of 0 equals negative 5. And so that's the point 0, 5 if you were graphing. The next one says solve f of t equals 0. Okay, so I'll write down f of t equals 6t minus 5, and then it says f of t equals 0, so replace f of t with 0. We'll add 5 to both sides, and we'll divide by 6. And I like fractions. 5, 6. Solve for f of t equals 0. That is my y value is 0, and my x value is 5, 6. So 5, 6, comma 0. That's the point we just found there. And then, just for fun, what about if we had put 2 in instead? Start with the equation, and then we'll put 2 in. And that becomes 6 times 2 minus 5, 12 minus 5, and what's that, 7? F of 2 is 7. Not too bad, I hope. Well, because you're going to do it yourself down below. I will change this in your packet, but I probably should have given you a different equation, so I will. It will be f of t equals negative 3x plus 9. Okay. All right, go ahead and try those 3 with this one. That's a good stopping place because next is group work. Okay, great. I'll talk to you in class.